So this first talk is about the human aspect of performance. How does performance affect the people who use the website? Introduction about myself. So, like I said, my name is Philip Tellis. I work at Akamai. My unofficial title is Principal Ram Distiller, Ram being real user measurement. So what we do is I'm the author of an open source library called Boomerang that collects performance data in the browser. So the JavaScript library sits in web pages, and as users browse websites, it collects data about the performance of that page and sends it back to our servers. And then we take that data and do a lot of analysis. So essentially distill it down to insights that we can provide our customers and community in general about performance things that they like. I am Blues Moon on Twitter, GitHub, and SpeakerDeck, and at some point after this this conference, probably these slides will all be up on my SpeakerDeck page. So, when we talk about performance, traditionally it's always been an operational metric. So the ops team typically looks at performance in terms of how servers are being utilized, are we making the best use of our network, is our operating system or our CPU running too hot, etc. But it turns out that performance is really a usability issue, right? Why do we really care about how hot our servers are running or anything else if we don't have users to use them? The whole point of building a business, building a website, building an application that users can use over the web is that we need users to use them, to be happy using them, and to buy things from our website, or essentially help our business grow by using their website. So anything we can do to make our users happy is good for business. Anything we do to make them unhappy is bad for business. So during this talk, we're going to look at a couple of things listed out there. Is your site hurting your users, or is it making them happy? How fast should your site be? Is there a threshold for it? How fast it should be? Is there a threshold for it? Too fast? Is adding a new feature, is it worth the performance cost? We can't get away from the fact that over time we're going to need to add more features to your site. The question is, should you add that at the cost of performance? Should you cut something else? How much development time should you spend on it? And finally, is improving performance worth the development cost? So in many cases in companies, the performance team, if there exists one, is typically what's called a cost center. Essentially, we don't generate profit, right? We don't have a product that you can sell to customers. And Akamai, that's different, because we are in fact a performance company, we sell performance products. But many other companies, performance is not a product. So unless you can justify the fact that I need these many people to work for so many hours or so many months on improving performance for no apparent income, you're not really going to get budget to do that. So we're going to try and answer those questions from the point of view of usability and how does performance actually drive business. So, right at the top, performance is usability. Is your site hurting your users? Right? What does it take to go from delighting your users to frustrating and hurting them? Really bringing out rage in your users. And I don't know if many of you remember this from several years ago on the internet. And there was, this is actually a staged video, but there was actually a survey done. So among Americans who who reported having computer problems, right, 36% reported verbally or physically abusing their computers. One person in Colorado was arrested for taking his computer out back and firing a shotgun at him. Right? The sheriff actually let him go, saying, "Who hasn't felt like shooting the computer sometime?" In Britain, 40% of people reported were physically abusing their computers when they had a problem with it. Okay? So this is not a small problem. People actually feel rage towards their computer. And there is actually a term called computer rage. It's well documented and well researched that people actually attribute human emotions to their devices. They spend so much time on their computers or their phones that it starts becoming a companion and they start attributing human emotions to it. Or they start deriving human emotions from it. So they can, in fact, get frustrated and can want to take that frustration out on the device. And sometimes just beating up your phone or your computer is better than beating up the person who built that website. What are the factors that lead to frustration or rage? Oh, the first is really wondering if anything is happening. Right? You click on a link and it's just blank, and you're wondering, is something happening? At that point, your initial reaction is, depending on the kind of user, there's maybe some anxiety or doubt. Did I do the right thing? Did I click on the right link? Did I in fact click? Then you go on to, is my internet connection down? What's wrong with this computer? Why is my computer so slow? Do I have a virus? There are all sorts of thoughts that go through a person's mind when they click on something and nothing happens. Then let's say the web page actually loads up, but you click on a link and nothing happens. Or you try to scroll and the scroll is really janky. Or responses are fairly unreliable or unexpected or inconsistent. Those are all things that make people feel a little afraid of using that site. So there was a study done a few years ago by Tammy Everts, who was at Radware at that time, she's now at SpeedCurve. What they did was they took two sets of users, and they put EEG headsets on all of them. And they made them browse through a bunch of websites, e-commerce websites, travel websites. And their goal was to do a bunch of shopping tasks. So essentially book a flight on a particular travel website or buy a particular pair of shoes on a shopping website. And on half of those users, they introduced an artificial 500 millisecond connection speed delay. What they noticed was that for that user, now neither of the sets were told that performance was going to be an impact, right? Or was going to be a part of the study. They were just told that you're supposed to measure the usability of this shopping website and the flow of getting from opening the website to actually completing your transaction. But what they found was for that 500 milliseconds resulted in a 26% increase in peak frustration of people using the website, and up to an 8% decrease in engagement. So, yeah.
What is peak frustration measured in?
So these are the standard ways of looking at the brainwaves to see whether somebody is frustrated or anxious or depressed, etc. It's yeah, good.
Is that 500 milliseconds in addition to what was taken?
Yeah. Okay. Good. So I'll get back.
Sorry.
So I thought you were going to do that.
I thought you were asking. It's okay.
So just looking at these patterns and seeing whether they match a frustrated pattern or whether they match happy pattern or an anxious pattern, etc. So there are standard libraries of patterns. And then looking at how frequently that happens over the course of the browsing session. So if that happens more and more, then the user is actually getting more frustrated. And so this was a pretty interesting study. It had never been, like, performance practitioners had never done a study where they looked at how they're actually affecting users mentally or psychologically. So that brings us to a term called perceptual dissonance, also known as sensory dissonance. So this is a part of cognitive bias or cognitive dissonance. It's the violation of the brain's predictive coding. So the brain's predictive coding is essentially that part of your brain which tells you, if you're trying to cross the road and you see a car coming, it tells you, well, can I make it across safely or not? It's because over time you have built up a experience in your mind that allows you to predict how long that car is going to take before it gets to where you will be. And when something violates that particular predictive coding, it leads to one of two things. Either you end up learning from the experience, which can be, in many cases, a happy thing. You're right, you could die. So Hopefully not when dealing with a car coming down the road, but with other cases, let's say you expected something to happen, but it didn't happen, and it was not a very bad experience. You probably learn from that experience and add to your ability to predict in future. The other thing that can happen is that you can get frustrated. And typically the difference is when this new piece of information that comes in, if it is in contradiction to all the information you already have in your brain, that's when it's going to start frustrating you. So what typically happens with websites, if we take the same concept to a website, is users have certain expectations of a website based on their experience of using the web over as many years as they have. Right? They expect that when they scroll, that the page will scroll smoothly. What actually happens in some cases is there may be jank or there may be UI lockup. You try to scroll and it scrolls a bit, but then locks up because it has to load more stuff over the network, or the CPU is busy doing something else, or you're trying to run some JavaScript. You click a link, they expect something to happen in response to clicking that link. And what happens if that's something that looks like a link but is not actually a link, right? And there have been cases where, again, studies done where users clicked on something that looked like a link and they keep clicking repeatedly, but nothing happens because that was just a heading that happened to be underlined in blue and color. Or you get misclicks where you're on a mobile device and there's a link to tap on, but it's so small and that particular website has disabled zooming, so you're trying to tap with your finger, but your finger's too large and it keeps going to the wrong link. Right? That's another frustrating experience. It's typically called a misclick. So the user might click again and again, and eventually it leads to something that we call rage clicking. These are all technical terms, but finally, they expect that you've got a fully charged phone or you've got a fully charged laptop and you're using the website, you expect your phone battery to last the same time it would last most days, right? My battery typically lasts about 6 hours, as long as I'm not watching a video or something. I expect it to last that. If it suddenly drains out in about an hour, that's going to be something frustrating to me. I'm going to think that whatever I was doing then, the website I was using, is the cause of that. And very often it is because this expensive JavaScript running, the CPU-intensive tasks running, there's animations that could be done using more optimal techniques that use JavaScript. There's animations that run when they're not visible. So you have a tab in the background, it's still running animations. Right? Luckily, browsers today actually reduce the how frequently they run, they update the frames. So request animation frame, for example, will run very frequently in the foreground tab, very infrequently in the background tab. And all these things can cause users to get frustrated because what's happening in reality is a violation of what their expectation is. And this new information doesn't make sense. It doesn't. They have no explanation for why this thing is happening the way it is, so they cannot actually add it to their corpus of information and predicted coding that they already have. So another study that was done by Ericsson, they do this every year. They do different studies, and again this time they studied people's heart rates, looking at pulses, and they found that the average rise in mobile users' heart rates was increased by 38%. This is equivalent to the anxiety of watching a horror movie alone. They also mentioned it's the anxiety of taking a math test, but I'm assuming most people in this room don't have that kind of anxiety. Maybe not everybody has that either. That's a pretty huge jump, right? To have your heart rate jump just because of a delayed web page. And they looked at both web pages and just video. So for example, you start playing a video and then after 6 seconds it pauses to pull in more content. And that's another thing, another cause of this 38% increase in heart rate. And there's a link there to the full study if you're actually interested in that. And finally, all of these negative emotions get enhanced because of something called negativity bias. What it means is typically that users tend to remember negative emotions more, or not users, but people in general remember negative emotions more than positive emotions. They tend to be more vocal about negative emotions. So you'll find there are more people complaining about a bad experience on Twitter, for example, than there are people praising a good experience. Right? Even though your parents may actually be skewed the other way, there may be more good experiences than bad experiences. You won't hear about it because people expect those good experiences. So well, it actually turns out you need to balance out bad experiences with a far more intense good experience. So if you have your performance is bad for a few pages, you need to have extremely good performance to balance that out, so that the users forget about their bad experience. And it's kind of hard to get really good performance if you're not already there. So there is another way. Apparently, there's something called active listening, where you can alleviate negative emotions simply by acknowledging that we have failed to meet users' expectations. So a good thing to do, and this again has been researched, there's some links down there, is if you feel that you may be missing users' expectations, you can apologize for that right up front. So if your page is loading and it's taking a rather long time to fetch assets that are needed, put up a message saying, hey, I'm sorry this is taking longer than expected, please hang in with us, we're dealing with some problems. And, I don't know if Google still does this, but a long time ago they used to show you how much time it took to get results. And it was often the case that they were just boasting that we're faster than the competition. We could run through like so many trillion results in 0.01 seconds. So, but it turns out that that number, just the existence of the number, nobody even looks at that number. But that number made people feel better when the results were slow. And said, hey, this thing is actually doing some work. And it's not just running off and finding the results right there. It's actually going and doing some work on my behalf. So I've projected human emotions onto that, and I feel connected to that. So I'm going to accept this slightly negative experience because I feel connected to this person now. Yeah.
Alleviating that, is that saying we failed to meet the expectations, or is it saying that something is not working right? Like in Firefox, if you got something that's slow, you'll get that little yellow bar. It says the script is slowing down your page, choose what you want to do with it. Is that this, or is this more like we know we missed the mark, things are going slow right now? Like which one is it?
Not the Firefox case. The Firefox case is basically saying this website is screwed up, just cut it out of your flow or something. Whereas, so it's essentially a third party saying, hey, I'm going to fix this for you. Those people suck. Whereas when you own up to it and say, all right, we know we suck. Right? We don't normally suck, but right now something's been wrong, and we suck right now. We're sorry for it. Please forgive us. That goes a long way to you just saying, all right, I'll give them a break this time. Right? If it happens every day, it's probably not going to work. They're going to then start thinking that's normal.
Is this something that is best to do in the moment, or can you also do retroactive, like, I don't know, someone visits your page, like, you have some sort of message or a banner, or some means to be like, hey, we understand our website was running slow last week, or something like that?
Well, there is a risk that the user might not come back.
Yeah.
So yeah, you could do that. There's also a little bit of a treat factor because then it says, hey, they knew I was here last week. So then they start thinking, well, they didn't tell me they were tracking me this long. Like, generally a week.
It might be a general message, like, well, last week we experienced.
But then it's not personal. So if an apology is not personal, then you don't feel good. If it's just like I'm making a press release saying, hey, I did this. That's nobody cares about that. That press release is not for me. It's for everyone else.
They've already been frustrated.
Yeah. So addressing that particular case, and it's easy to do, right? You can always have that little text in your HTML. Just display it when, for example, your JavaScript's loaded, but you know your DOM content ready is not 5 yet, and it's been 1.5 or 3 seconds or whatever. The threshold you decide makes sense. Any other questions about this? The next thing I want to look at is accessibility. Now, typically when we talk about accessibility, it's making your website accessible to people of different abilities. And I want to talk more about accessible to in general your audience, right? Whether that includes people of different abilities or devices of different capabilities or people from different parts of the world, they're all fit into the accessibility umbrella. So there's a good tool to use, sitecost.com. Pretty easy, it uses web page test. Essentially what it does is runs through your website, tries to, it fetches all the assets, sees how big that was, how much time it took, and then it compares that with the data cost of the cheapest plan on the most popular provider in that particular country. So it picks data from the World Bank and from various international sources, saying for each country, who's the largest or the largest two mobile providers, what's the cheapest plan they have, both prepaid and postpaid, and how much would it cost to download this amount of data. And then compare that to the gross national income of that country. So, for example, this is the PHP Arch website, and on Vanuatu, just loading that web page would cost 1.28% of a person's income in a day. Right? So if they want to load that page 10 times, browse through 10 pages, they've just blown through 10% of their income, or 12% of their income. Right? This is actually a light page. Wikipedia is based on this. If you pick something like Facebook, or even the light version of Facebook, that's already a baseline 10% of Vanuatu or Mauritania or Madagascar's GMI. So what does it tell a user when you're saying, hey, my site is so important, you need to spend 10% of your income just to view the first page, but I don't care so much about about giving you a performant experience. So keeping these things in mind, saying my target audience is in this part of the world, this is how much it's going to cost them to actually use the site. Can I provide different experiences to different people based on what I already know about the network, about what it costs to access the website, right? The US is right down at the bottom here. I think Canada's not even on this list, it's further down there. 0.12% of GNI. So if we're constantly building for people out here or in this range or below this, then we're not dealing with the users out there. And data cost is just one of it. There's also power costs or energy costs. So a study done by the American Council, or I forget, it's one of the energy councils, shows that each gigabyte of data uses 1.6 kilowatt hours of client energy. It uses 5 kilowatt hours in total, including data centers and network transfer, so ISPs and things like that. But 1.6 on a device, so either a laptop or a phone or something like that. And that can add up. If you keep looking at the number of gigabytes that people have to download just to get a web page, sometimes it's half a gig for a single website. Sometimes people have these images that they typically put into no script tags that tend to be 8 megs or 15 megs in size because nobody actually saw that in development. And the first time somebody actually loads it without JavaScript on, it suddenly blew up the data plan. And it turns out these are the people who load it with JavaScript the same. YouTube, for example, did an experiment many years ago, and this actually went into production, where they tried, because of the cost of using the website for people from smaller countries, people from more expensive data plan countries, they decided to reduce the weight of the website. And they spent a lot of time optimizing, reducing the weight. In testing it, the performance improved significantly. But what they found was, once they looked at the aggregate data that they were collecting, their median and their 95th percentile all got worse. So they actually made a faster site. So this was very strange. They were running an A/B test. They quickly decided to roll back the A/B test. But then they went back and started looking at the data. Right? What was it that caused this unexpected shift, where a faster website actually looked slower? And it turned out, because of the fact that they made it lighter, more users who just could not use the website before. Right? It was not loading, they get a 500 error or get a timeout or something. They were suddenly coming into the funnel. because these users now are getting a slow experience, but it's better than no experience. Right? And it turns out users from different parts of the world have different thresholds for what slow means, based on what their expectation is, based on what their experience with the rest of the web is. So for somebody, 16 seconds may not actually be slow. I remember when I started using the web in mid-90s, 16 seconds was not slow. It would actually take that much time to, it would take more than that much time to connect to the internet. Another experiment done by Dine, they tried to increase, well, they didn't try to increase the page width, but they looked at all of the assets on the page and they started combining images, small images into an image sprite. And that ended up increasing the total download size of the page. But it also resulted in reducing the number of HTTP calls reduced by 21. So a pretty significant reduction in number of HTTP requests, but an overall increase in page weight. And that actually did improve, resulted in a faster experience overall, no reduction in users. So they decided to roll with that. And so far I've talked about these things affecting people in countries where the high data plans or slow internet. But it turns out it's not actually countries with slow internet. It's countries that we're fairly familiar with, like the US, and not even small cities where there's not good mobile coverage or not good internet coverage. But a train ride from, this is a train ride from DC to New York City. Fairly well populated area, should have fairly good coverage. Turns out there's, in the worst case, 3 seconds of latency on the web. 3 seconds is pretty bad. I mean, just think about it, it's 3 seconds to, before you get the first byte. There's still more to happen after that 3 seconds. So, and in the best case, there's 100 milliseconds. So 100 milliseconds you might think is not a lot, but it adds up. If you're doing multiple requests, 150 requests on a page, multiplied by 100 milliseconds, that's 15 seconds, right? So you're dealing with a lot of latency. And it turns out that this is not just the US. People have reported in the UK, in various other places. Somebody mentioned he went to his in-laws' place to fix their internet. Turns out they were getting 0.42 megabits per second. Right? They replaced the router and got it up to 0.67 megabits per second. He was using his 3G phone in the house, getting 30 megabits per second. So it's like there is coverage, but people don't have access to it, or they haven't used it. So you still need to think about people who are using these kinds of informations. And this kind of packet loss can then result in large assets not showing them. Right? JavaScript, CSS images. Those are assets that load after your page. And if there is packet loss, if you have a large JavaScript file that's say larger than 15 kilobytes in size, that requires multiple round trips to send acknowledgements back to the server. If there's a packet loss that causes any of those acknowledgements to fail, the browser is going to have to retry the whole file. Or it's going to give up at some point and say, I've retried this too many times, this JavaScript's not loading, here's your web page without that JavaScript. Right? Will your web page work without that JavaScript? And then there's battery. I see most people are actually plugged in, their laptops are plugged into power. Right? Everyone does get anxious when their power supply starts dropping. So it turns out that it's not just psychological, it's also devices have built-in protections, right? So when you're, if you have an Android device and your battery drops below 10 or 15%, it's configurable, it'll switch to battery saver mode. What it does in battery saver mode is it downsamples your CPU so that you actually get a reduction in performance in order to prolong your battery life. That results in a 28% reduction in performance in battery saver mode. So when we've looked at our data, there's a clear switch when it goes from, well, we didn't look at an absolute number because the number is configurable, but we took 8% and 30% as the two extremes and looked at the difference in performance, and there was a clear drop in performance between those two levels. There's also 78% increase in long tasks. I'll talk about long tasks in a subsequent session today. But essentially, tasks that take a lot of time to run, JavaScript tasks that take a lot of time to run. There was a 75% increase in those. And a frame rate reduction from 16 frames per second to 10. Now, you know that 16 FPS is typically what you need for smooth animation. So if you're animating and battery drops below, say 10%, you're suddenly going to get a non-smooth animation. Not just that, but that animation is going to stop other things from happening on the website. The cool thing is you can actually detect battery level in JavaScript and say, okay, I detect batteries going below a certain level, let me turn off all these expensive things on my site. Right? If I have animations, I can turn it off at that point. If I have something else that's just maybe a carousel that's running around fetching lazy loading images, I can turn off all of those things when I detect battery going down. And finally, there's device capabilities. So not just high-powered devices with good batteries that might run out in a few hours, but the average device across the world. So it turns out that if you look at the largest markets, Brazil too, although it has pretty expensive phones, but the average for selling price of a phone, so that's the phone that most people buy, is in the $150 to $200 range. That is typically not your $900 or $1,000 iPhone or Pixel that most of us in tech will tend to use. In the US, it's around $340. So people tend to buy cheaper devices because they don't necessarily have the same requirements of a device that most of us do. But that also means those devices are lower power. The Alcatel Go phone, for example, is one of those $100 devices. It sold out at Amazon in about a day. That's how popular it was. I don't know who bought it because we don't have that data. We do know it sold out very fast. They had to order some more, and it was in back order for quite a while. And that's a good phone to test on. It tells you what people who have these lower power devices will experience. Right? Typically lower CPU, typically lower bandwidth capabilities, lower battery power on the radio, which means you can actually get a good signal from very far away. And that all translates into slower experiences. So will your site work well on a device like that? Which lastly brings us to the measuring emotion part. So we've figured out that there's all these things that affect emotion, but can we tell when a user's on a website, are they happy? Are they frustrated? Are they getting into a fit of rage? There's a couple of ways you can do that. You can ask the user. You might have seen surveys pop up every now and then. At the end of your session, would you like to give us feedback on your browsing session? Or you also see it at various physical locations. At IKEA, for example, in the restaurant, there's a little thing when you're exiting saying, did you find your experience good, bad, or average? And there's three faces there, smiley face, a neutral face, and a sad face. There was one at the restroom at the airport yesterday. When you come out, was this restroom clean or not? So ask the user. I don't know how many people do that. I will not touch a button in a public restroom. Especially after I've already washed my hands on the way out. You can measure bounce rate, conversion rate, and something we call the median lethal dose, which I'll talk about a little later. Something called rage clicks, which we spoke about, cursor thrashing and wild mouse, facial analysis, and of course, like we've already seen, you can use an EEG device that you put on people's heads and measure it. They cost about $150 now, at the low end about $700 or $1,200 on the high end. You can actually buy them yourself. People use them for gaming devices, they can brain control games. It's pretty cool if you're into that stuff, but I don't know if you want to ship one of those to every one of your users to find out how they feel when using those. So the ones we will talk about are rage clicks, and I'll go into more detail a little later. Rage clicks occur when users rapid fire click on a single link or within 10 pixels of a single link. It's the digital equivalent to cursing to release frustration. Cursor thrashing or wild mouse is typically the way people move their mouse. And I don't know if you've done this yourself or you've seen other people do it, but things are loading, and if you see a spinner or you see this content that you know is there and you're waiting for it, but it's not showing up, and just shaking your mouse to see, or is my computer still alive? Right? That's my mouse on. Or are these links still changing color when I hover over them? Just is something happening? Right? It's all part of that. Is something happening? So turns out that there is a correlation between how people feel and how they move their mouse. Right? People who are angry are more likely to move the mouse in a jerky and sudden fashion. So there'll be periods of no movement and then a lot of movement. People who feel frustrated, confused, and anxious, they're less precise and move it at different speeds. So you might find a lot of movement, but they keep fluctuating in the speed of movement. And like I mentioned, there's brain devices. There's actually the website if you want to buy one. It's called emotive.com. And web facial analysis is the JavaScript library if you want to use that. Probably violates a lot of privacy regulations. We don't do this either. So using all of these signals, come to a question of how fast should we be? So user expectations are relative, like we've already seen. They have expectations that are built up, the experience over time. The experience with other websites, maybe your competitors' websites. So typically you want to be faster than your competitors, right? So that if they find anyone slow, it's not you, it's your competitor. They don't go there, they come to you. But you also want to be faster than your previous self. Right? As you get faster, users expect you to be even faster. Right? They say, hey, my internet connection's been upgraded. I need a faster website. Or I've got a new laptop, I've got a new phone. Website should be faster. Doesn't quite work that way, but I'm trying to explain it to everyone. Right? So you need to make constant improvements to your site. So you need to be able to improve as infrastructure improves, but improve faster than infrastructure, because you can't just expand to use up all the available bandwidth. There's also a tool called Crux. So it's Google Chrome sends a lot of telemetry back to Google's websites, and they make the data available. And Akamai, we built this tool called Crux benchmarking. You can visit this website, type in any URL, and if it is in the Crux database, we will pull that out and also compare it against other people in that space. So this is looking at the news space. I just put Wikipedia against news websites. Wikipedia is pretty fast. It's interesting to see the comparison between other news websites. They're obviously looking at each other to see who's faster. There's something we call the median lethal dose that I mentioned earlier. It's the point at time when 50% of your users leave the site. So they decide that, hey, this experience is too frustrating, I'm going to go. Either it's too slow or their expectations were not being met, with too many jobs. There was something like that. So it's interesting, it's good to see what was causing people to leave the site. Important to note, it's not a single magic number. It could be different for different websites, it's different for different pages on the website, and it's different for different kinds of users of that website as well. And so we just looked at LE50 for a couple of different websites, and just comparing US users to Canadian users, turns out that users' expectations are very different from that same website, and for different pages. So Canadians were way more patient for the homepage. Americans didn't even bother with home pages that didn't load up pretty quickly. The account sign-in, Americans tended to be more patient than Canadians. With the product page, it was pretty much equal. So if your product page didn't load in a certain amount of time, nobody stuck around. Turns out that product pages and search pages are the most important pages to look at on most retail websites. Homepages are actually not very important. Most people don't visit the homepage. They tend to get their site from a search engine, so they end up directly on a product page or a site page. That was an interesting result we found. So, just based on that, it's important to rank your pages by their impact on conversions or activity or whatever is important to your business. What's the correlation between various timers, your load time or your visually ready time or interactive time on conversions for each page, and decide which page is the most important for that, and then look at how that particular page is affecting your customers. Different rates like the error rate, the cursor flashing rate, etc. We don't know why, but our studies consistently show that users expect interactive at around 1.3 times the visually ready time. So if your page is visually ready at 1 second, they expect to be able to interact at 2.3 seconds, or between 2.2 and 2.5 seconds. If your page is not interactive at that point, that's when users start getting frustrated. And we've seen this with rage click analysis mainly, and there's a pretty consistent straight line, which you'll see in the, I might have it in a couple of slides. Users' expectations, they expect to be interactive after visually ready, and if your page is not interactive after the onload event has fired, that's the most frustrating that it will cause, the most frustration it will cause people. I'm going to skip over a slide because I'll cover it again in the next in more detail. This was the correlation line we found, first interaction versus visually ready, and the number of rage clicks. So as you can see, the number of rage clicks is really concentrated on that 1.2 to 1.5x line. And how fast is too fast? So, really, there is no limit, right? And if you ask me at Akamai, no, there's no limit. We want to sell you all the performance optimization that we can so that you load your website in 0 seconds and cool stuff like that. But it turns out that there are diminishing returns, right? At some point, yes, you can say my conversion rate is going to keep improving if I improve performance. If I go from 5 seconds to 4 seconds, you will see pretty good improvements. 4 seconds to 3 seconds, you'll still see good improvements. But then you start getting to a point where 3 to 2 seconds did not get you the same returns that 5 to 4 seconds got you. And you see a lot of these studies that say Amazon said 100 milliseconds change in performance led to 5% improvement in conversions. Which 100 milliseconds, right? Was it the 100 milliseconds between 9.1 and 9 seconds, or the 100 milliseconds between 1 and 900 milliseconds? 1 second. Obviously, those two are very different. MSN, for example, has they used to complain to us a lot for way back when I was in a different company for an 80 millisecond latency that we sometimes added to their web page. Turns out 80 milliseconds was a significant amount of their load time. They were an 800 millisecond page, and 80 milliseconds was 10% of the load time. So we reduced that. We got it down to 10 milliseconds, which is acceptable. How much you try to improve is relative, and the amount of development cost and effort you need to put into those incremental improvements increases probably exponentially. It's not necessarily easy to get from 1 second to half a second. Not as easy as it is to get from 3.5 to 3 seconds. The better question is, will adding a new feature that may cause performance problems, will that feature delight your users enough to negate the performance problems it causes? So rather than saying I'm going to make my site faster by 500 seconds, 500 milliseconds, say if I'm going to add 500 milliseconds to the load time, is that going to be worth it or not? And that's where I'm going to leave you for this session. So thank you. I do have a lot of references in this presentation to all the research that was done, which will be available on any questions? I know we're right at time. We have a few minutes, right?
Fonts on Google Page Speed.
Thoughts on Google PageSpeed as a service or just as
Just as the metrics it pulls down, I mean, it looks for time first by, it looks for.
So yeah, we do look a lot at Google PageSpeed numbers as well. One thing to note is it is kind of a synthetic measure in the sense that it uses a bot to measure how long it took. Chrome Insights or Chrome user experience, that's the crux, tends to be more round-based. So if you're looking at Google data exclusively, then look more at crux data. PageSpeed gives you a good benchmark, but it's not looking at all of the users. So using a run tool, which just happened to have written, it's an open source library, so you can put it onto your website, whether on any others that you can. Tends to give you numbers for all of your users, specifically the long tail, not just the medium, not just those that Google is emulating.
Does Boomerang give us access to the so
Yeah, so a lot of the code that I'll talk about in the next session is actually straight up. And I had a link at the top, there's a link in there as well. It's github.com/akamai/. Any other questions?
I just thoughts on that line that has a concentrated range clicks around the one line, which is very strange, I would say. Is it possible that some cross-section of your users, kind of certain browser that they didn't report anything until that it's reached?
It is, yeah, I understand what you're saying. So is it possible that basically there's no data, so this is survival bias.
Yeah.
There's no data for anyone who is faster than that. And yes, that is a possibility. The thing is we do have data, like you can see there are some points that are in fact in this range and are in fact in that range. So there is data for cases where visually ready and first interaction were at a different level to each other.
So I was saying, like, is it possible that the kind of Chrome, for example, doesn't report clicks until certain thing happens?
No, there are no browsers that don't report. There are maybe cases where the JavaScript hasn't loaded yet, so you're just not capturing it. So even though we load the JavaScript and we send the data back, it is not loaded early enough to capture the first few clicks. But I'd say at least the sites that I looked at, we're loading early enough that that's no problem. We're in the head, we're loading asynchronously. Typically we cache for 7 days, so the load time is 0 seconds. Not 0. Typically under 5 milliseconds to load from my memory that is cache. That's typically the percent. But yeah, I mean, we're constantly trying to look at this data and see, is there something wrong with that methodology? Because if it's too good to be true, it may not be
It's like, yeah, like